Next is thermometry. Now what is this thermometry? Thermometry is the act of measuring temperature with precision and accuracy is known as thermometry. Now whenever the temperature is measured, it is measured with reference to certain property. That property changes with respect to temperature, and with the help of that change in property we can determine change in temperature. Okay, this is how any thermometer functions. Now I will tell you one example, and I will also tell you how the first thermometer was made. So let's suppose, for example, suppose we are having a mercury thermometer, that is the most commonly used thermometer. Now how is this thermometer made and how is this thermometer calibrated? Now we know two different points. First is the ice point, the melting of ice point, and second we are having a boiling water point. So what he did was, initially the bulb of that thermometer, which is filled with mercury, that is kept under the melting of ice, and whatever was the volume of mercury, he marked it as 0 degrees Celsius. Okay, then what he did was he removed that bucket of ice and he put that bulb into the boiling water. And again, because of the temperature change, the volume of the mercury changed and that mercury level rises up to a certain level. He marked it as 100 degrees Celsius. And then he divided this into 100 equal parts. Between 0 degrees Celsius and 100 degrees Celsius, he divided the complete scale into 100 equal parts. Now whatever temperature we want to measure, unknown temperature, suppose T temperature we want to measure, we are putting that bulb into the contact with that T temperature. Now let's suppose that bulb will rise up to the 50th point, that mercury will rise up to 50th point. Then we can conclude that the temperature of that unknown temperature T is nothing but 50 degrees centigrade. This is how thermometers are made and thermometers are used. So what I mean to say is the thermometric property which is used here is volume, because we are just checking the change in volume of mercury only. We are not directly measuring the temperature, we are just measuring the change in volume of the mercury, and with reference to that change in, with the help of that change in volume of mercury, we are measuring the temperature. So this is the thermometric property because of which we are able to measure the temperature. This is called as a thermometric property, and the corresponding substance which is used for that thermometric property is the thermometric substance, like mercury in this particular case. Okay, next are the types of thermometer. Now what are the types of thermometer? So the very first type of thermometer is liquid in glass thermometer. And these are in fact most commonly used thermometer. We have discussed about the mercury thermometer. That mercury thermometer is actually an example of liquid in glass thermometer only. Okay, so these are basically of this can be basically classified into, first is mercury thermometer, and second it can be either alcohol thermometer. Mercury thermometer means the liquid used inside the glass is mercury, and alcohol thermometer means the liquid used is alcohol. And in mercury thermometer, the temperature which can be measured this is basically used for measuring high temperature. Okay, this is used for high temperature measurement of the order of up to 300 degrees centigrade. Okay, that means with mercury thermometer you can measure the temperature up to 300 degrees centigrade. Okay, but in alcohol thermometer this is basically used to measure the temperature, to measure very low temperature. Okay, this is used to measure low temperature of the order of up to minus 111 degrees centigrade. Okay, so if we want to measure very low temperature, negative temperature, we can use alcohol thermometer, and if we want to measure high temperature, we can use this mercury thermometer. And as I told you, the thermometric fluid used here is mercury and alcohol respectively, and the thermometric property here is nothing but volume. Okay, based on change in volume we measure the temperature. Okay, so these are basically expansion and contraction type of thermometer. Okay, you can call it as expansion and contraction type of thermometer. Getting this or not? Okay, so this is first type of thermometer, liquid in glass thermometer. Next type of thermometer is the gas thermometer. Now this gas thermometer are of two types. It can be either a constant pressure thermometer or it can be constant volume thermometer. can be constant pressure thermometer or constant volume thermometer. Constant pressure thermometer means if pressure is constant, then as we know PV is equal to RT. If pressure is constant, then obviously V is directly proportional to T. That means if the volume is increasing, obviously the temperature will increase, okay, or we can measure the change in temperature based on the increase in temperature based on increase or decrease in volume. Getting this now? So these are constant pressure type thermometer. Obviously the thermometric property used here is volume. In constant pressure type thermometer, the thermometric property used is volume. Okay, that means from here we can write it as V1 by T1 is equal to V2 by T2. Getting this? Similarly, second type of thermometer is constant volume type thermometer. Okay, here since volume is equal to constant, so pressure is directly proportional to T, or you can say P1 by T1 is equal to P2 by T2. That means based on the change in pressure, we can determine change in temperature. Okay, and thermometric property here, as we know, will be the pressure. Okay, so this is the second type of thermometer, which is the gas thermometer. Okay, so next type of thermometer is the resistance thermometer, and as the name suggests, here the thermometric property is resistance. As we know that as temperature changes, the value of resistance also changes. So based on this principle, this thermometer is designed. So what we are doing this is actually based on the principle of Wheatstone bridge. We all know about Wheatstone bridge principle. We have 4 different resistors, P, Q, R and S. Okay, out of which P and Q resistors are having fixed value. This S is having variable value. We can change the resistance of this S, and this R is the unknown resistance. Okay, now what we can do here is, as we know from Wheatstone bridge principle, we know what P by Q is equal to S by R, or you can say this R is equal to Q into S by P. Okay, what we do here is, suppose we want to measure the temperature of whatever temperature we want to measure, we keep that in contact with this T degrees with this R resistor. Getting this? Okay, the temperature which is to be measured is kept in contact with this R resistor. Then according to this temperature, the value of this resistance will change. Okay, now what you can do is you have to adjust. Now according to the resistance, this value, the value of this current will also change. Okay, हमको क्या करना है, हमको इस करंट को जीरो करना है. Okay, यहाँ से कोई करंट पास नहीं होना चाहिए. Wheatstone bridge का प्रिंसिपल क्या है, whatever current is getting through this should pass here, और यहाँ से जो करंट आ रहा है वो सीधा से यहाँ जाना चाहिए. That means यहाँ कोई करंट नहीं होना चाहिए. ओके, तो यहाँ जीरो करंट है, सो फॉर जीरो करंट के लिए क्या करेंगे, वी विल एडजस्ट दिस बिकॉज दिस इज अ वेरिएबल रेजिस्टर, उसको हम एडजस्ट करेंगे टिल द पॉइंट वी आर गेटिंग जीरो करंट हियर. ओके, एंड वंस यू हैव दिस जीरो करंट हियर, you know this value, you know this value, you know this value, you can determine the value of this R. So this is how you can determine the value of this unknown resistance. Okay, and based on the value of this unknown resistance, you can now determine the value of temperature. At what temperature we are getting this resistance. Okay, by relation RT is equal to R naught 1 plus AT plus BT square. Okay, where RT is resistance at T degree centigrade, R naught is resistance at 0 degree centigrade, A and B are constants, and T is the unknown temperature which we want to determine. Ultimately we are using this as a thermometer, so we want to determine the temperature, unknown temperature. Getting this? So R naught is the resistance at 0 degree centigrade, RT is the resistance at T degree centigrade. Okay, so if you have the value of this RT and R naught, okay, RT is the value, the resistance at T degree centigrade, R naught is the standard value, resistance at 0 degree centigrade. Okay, then you can determine the value of this T, provided you must have the value of this A and B. Okay, now how to determine this value of A and B? So what we can do here is same thing which we did in the liquid thermometer, we use the calibration there. Same thing we have to do here, we have to calibrate this and determine the value of this A and B. Okay, so उसमें हम क्या कर सकते हैं, what we can do here is initially इसको हम 0 degree centigrade of melting ice के contact में लाएंगे, and we will find out the resistance at 0 degree centigrade. The resistance will be R naught. Okay, so we have the value of this R naught now. Getting this? Okay, and here this RT is also equal to R naught, so we have one relation, 1 plus AT plus BT square is equal to 1. We have the value of temperature, A और B के फॉर्म में एक इक्वेशन आ गया. Getting this not? Similarly, we will now bring this in contact with 100 degree centigrade steam, vaporizing steam. Okay, now again what will happen, again this RT, the value of this RT we can determine, resistance at 100 degree centigrade we can determine. We know the resistance at 0 degree centigrade. So from here we will get other equation in terms of A and B. Getting this now? Okay, so we have two equations, two relations, two variables, so we can determine the value of this A and B. And once you have this value of A and B, now at any unknown temperature, you can determine the value of this resistance RT. You can determine the value of this resistance from here, and with the help of this, if you have the value of this resistance at T degree centigrade and resistance at 0 degree centigrade and A and B, you can determine the value of unknown temperature from here. Getting this now? Okay, so this is how this resistance thermometer works. Next type of thermometer is thermocouple. Okay, this is also used to determine the temperature. Now what we do here is, this actually is based on the principle of Seebeck effect. Okay, what we do in this thermocouple is, we take two dissimilar elements, two dissimilar metals. One element is of higher order and second element is of lower order, and we form two different junctions. Okay, two different junctions are formed such that one junction is kept in cold part and second junction is kept in the hot water. Okay, this is the EMF, and because of this temperature difference we get certain EMF, and based on that EMF we can now determine the temperature. Okay, the relation between EMF and temperature is E is equal to AT plus BT square. That's it. Okay, so if you have the value of this EMF, you can directly determine the value of temperature, provided you must have the value of this A and B. And value of A and B, similarly, we can determine in the similar way. First, keep this in contact with 0 degree centigrade and get the value of this E. Okay, we have the value of E and T now. Then keep this in contact with 100 degree centigrade boiling water. Again, determine the value of E. We have the value of A and T here. That means we are having two equations in terms of A and B. So from there we can determine the value of this A and B. I am not getting into much details of all these things because of everything you have already studied in your physics. Okay, so I am just telling you the overview. Okay, so with the help of this equation, you can determine the temperature. This device is nothing but the thermocouple. Getting this not? Next type of thermometer is pyrometer. Okay, this pyrometer actually works on the principle of radiation, and this is basically used to determine the temperature of distinct object, the object which is far away from us and which is having very high temperature, like that of sun, like that of furnace. If we want to calculate the temperature of furnace, we can determine with the help of this pyrometer, with the help of radiation only. Okay, so this pyrometer is actually used to determine the temperature of distinct object and having very high temperature, and it works on the principle of radiation. Okay, next is the magnetic thermometer. This magnetic thermometer works on the principle of adiabatic demagnetization. Okay, and this thermometer can be used to determine very low temperature, and when I say very low, I mean very low temperature of the order of minus 269 degree centigrade. Such a low temperature can be determined with the help of this magnetic thermometer. Okay, so these are all different kinds of thermometer. Okay, next is the temperature scales. Temperature scales. We know for measuring temperature we use different scales like Celsius, like Kelvin, like Fahrenheit. These are different scales for temperature measurement. और एक स्केल से दूसरे स्केल में हम कन्वर्ट कर सकते हैं. देयर इज अ फॉर्मूला फॉर कन्वर्जन, यू माइट बी नोइंग दिस. इट इज C minus 0 upon 100 minus 0 is equal to F minus, this actually 0 is nothing but the ice point in Celsius scale. The ice point, as we know, is 0 degree Celsius and the boiling water point is 100 degree Celsius. So this is actually C minus T ice point upon T steam point minus T ice point. Okay, so this is for Celsius. Then for Fahrenheit, as we know, ice point is 32 Fahrenheit and steam point is 212 Fahrenheit. 212 minus 32. Okay, likewise we can convert, so with this we can convert from Celsius to Fahrenheit and vice versa. If you have got any temperature scales, X, Y, Z, whatever be the temperature, let's suppose you are having a new temperature scale, let's suppose rho, and in this temperature scale, let's suppose the ice point is T ice and the steam point is, let's suppose, T steam. Okay, you just need to know the ice point and steam point in that particular temperature scale. Then you can convert any temperature in that particular temperature scale. Okay, how? This will be equal to rho, which is a new temperature scale, minus T ice upon T steam minus T ice. Okay, so likewise you can convert this. If you have got any suppose 50 degrees centigrade, you can put the value 50 here, and in terms of rho, what will be the value you can determine. So from one scale to other, you can convert the temperature by using this temperature scales. Now we will look into few very important definitions. The very first definition is that of 1 Kelvin. Okay, now how can we define this 1 Kelvin? This 1 Kelvin is defined as 1 by 273.16 of triple point of water, of temperature of triple point of water. Okay, 1 Kelvin, how can we define? This 1 Kelvin is nothing but 1 by 273 of 1/6 of triple point of water, and triple point of water, as we know, is nothing but 0.01 degrees centigrade. Okay, triple point is that point at which all the three phases exist simultaneously, solid, liquid and gas. Okay, so for water, that triple point is 0.01 degrees centigrade. Okay, and we can define on the basis of that triple point, we can define 1 Kelvin. So 1 Kelvin is defined as 1 by 273.16 of triple point of water. Okay, next is the definition for absolute zero pressure. Absolute zero pressure. Now what is this absolute zero pressure? Now we all know that the atmospheric pressure at which we are continuously living is nothing but 1.01325 bar. This is our atmospheric pressure. Continuously this much pressure is exerted upon us. Now what does this mean? If atmospheric pressure is 1.01325 bar, okay, if I decrease this pressure, there will be a certain point in this particular scale, there will be a certain point where this atmospheric pressure is 0 bar. Getting this or not? Okay, so the point where the atmospheric pressure is 0 bar, this 0 bar pressure is nothing but absolute zero pressure. Getting this or not? Okay, so this 0 bar pressure is nothing but the absolute zero pressure. और absolute zero pressure को हम कैसे define कर सकते हैं? Absolute zero pressure is dead pressure where molecular momentum becomes zero. जहाँ पर molecular momentum zero होते हैं, that particular pressure is the absolute zero pressure. Okay, and what will happen if the temperature of if at constant volume, if I am increasing the temperature? Okay, now though, so the what will happen if suppose if we are having a constant volume flask and air is having inside this, and we are increasing the temperature. Okay, now what will happen? This molecules will start moving at the faster pace. They will start striking with this walls of the container, and more they strike with the walls of the container, the pressure will increase more. जितना ज़्यादा wall से strike करेंगे, more will be the pressure. Getting this? So absolute zero pressure means where molecular momentum becomes absolute zero, और जितना ज़्यादा उसका molecular momentum होगा, more will be the pressure. Getting this or not? Now what will be the pressure increase of any particular gas? If we are increasing the temperature by 1 degree centigrade, suppose we are increasing this temperature by 1 degree centigrade, what will be the pressure increase then? Okay, so that pressure increase with per degree centigrade, the pressure increase is 1 by 273 of the pressure at 0 degree centigrade. That means जितना भी pressure हमारे पास 0 degree centigrade में है, okay, उसका 1 by 273. This much part will increase per degree rise in temperature. 1 degree rise in temperature में इतना होगा. Suppose we are increasing this by T degree centigrade. So total increase in pressure, this is increase in pressure is nothing but T by 273 into pressure at 0 degree centigrade. Okay, so this is increase in pressure. That means this will be equal to T degree centigrade minus P 0 degree centigrade. Getting this? So from here we can determine this P T degree centigrade, which is equal to P 0 degree centigrade plus T by 273 of P 0 degree centigrade. Getting this on? Okay, so this is how we can determine the pressure at any definite temperature. Suppose we want at T degree centigrade, so this is equal to P 0 degree centigrade plus T by 273 of P 0 degree centigrade. क्योंकि per degree rise in temperature कितना increase हो रहा है? P 0 degree centigrade का 1 by 273 part. That means 0.36% for per degree increase in temperature. 0.36% of the pressure at 0 degree centigrade हमेशा increase हो रहा है. Getting this or not? And this is for all the gases. Similarly, volume at T degree centigrade, volume भी same ratio में increase होता है. Volume at T degree centigrade is equal to volume at 0 degree centigrade plus T by 273 of volume at 0 degree centigrade. Same thing for per degree centigrade rise in temperature, the volume will increase by 0.36% of the volume at 0 degree centigrade. That's it. This is how you can define this. Getting this or not? Okay, and one important thing, very important thing, this is true for each and every gas. हर गैस के लिए ये true है. Unlike in solids, solids में क्या होता है? If we are having different solids, every solid is having different thermal expansion coefficient. Okay, तो सबकी जो वॉल्यूम चेंज होती है वो डिफरेंट होती है. For per degree centigrade rise in temperature, that depends on thermal expansion coefficient, as we know. Okay, but in gases, the pressure increase or the volume increase for any gas for per degree centigrade rise in temperature is 1/273 of the pressure or volume at 0 degree centigrade. Getting this or not? Okay, now this from here we can draw very important conclusion that अगर मैं इसको in the form of graph अगर मैं draw करना चाहूँ, okay, if I draw the graph between P and T, pressure and temperature, okay, so at 0 degree centigrade we are having certain pressure. At 0 degree centigrade we are having the pressure which is equal to P 0 degree centigrade. Okay, and as the temperature is increasing, the pressure is increasing linearly. Pressure is increasing with respect to temperature linearly. That means from here I will get one linear line like this. Getting this or not? Okay, similarly for volume, same graph we can plot it for volume as well. V versus T graph. Okay, at 0 degree centigrade we are having certain volume, let's suppose here. Okay, and with increase in temperature this volume is increasing. Okay, now what does this mean? This means that here we are having a certain volume V 0 degree centigrade. अगर मैं इस स्केल को पीछे की तरफ ले जाऊँ, okay, if I am extending this scale backwards, so what will happen? There will be a point somewhere in this temperature line where this temperature will be 0. Okay, एक ऐसा point आएगा जहाँ पर हमारा temperature 0 है, but at the same time at that point this volume is also 0. That means volume जिस point पे 0 होगा, at that particular point the temperature will also be 0. PV is equal to MRT as we know. Okay, if volume is 0 then temperature is 0. अगर मैं constant pressure पे volume decrease कर रहा हूँ या or I should say अगर मैं temperature decrease करना हूँ, at the same time the volume will decrease, and at a point when volume becomes equal to 0, there we will have the 0 Kelvin temperature, absolute 0 temperature what we call. Okay, तो यहाँ पर हमको temperature जो है वो 0 मिलेगा, and this temperature is nothing but absolute 0 temperature. Getting this or not? जिसको हम 0 Kelvin कहते हैं, 0 Kelvin, or you can say -273 degree centigrade. Okay, so this is nothing but the absolute 0 temperature. But is it possible to attain this temperature? Okay, I mean कि अगर क्या ये possible है क्या कि किसी भी molecule की, किसी भी gas molecule की volume जो है वो 0 हो जाए? Volume 0 हो रही है, this means that उसका existence ही खत्म हो गया. Okay, there is something in front of us और सडनली हमने उसका टेम्परेचर डिक्रीज किया, उसका एग्जिस्टेंस खत्म हो गया. ओके, दैट इज लाइक अ गोस्ट. ओके, सो इन एक्चुअल सेंस इट इज़ नॉट पॉसिबल कि किसी भी चीज़ का एग्जिस्टेंस आज तक साइंस ने खत्म नहीं कर पाया. ओके, सो दैट वॉल्यूम ऑफ दैट पर्टिकुलर गैस कैन नॉट बी 0, देयरफॉर attaining this absolute 0 temperature is not possible. So absolute 0 temperature lies in scales only. सिर्फ स्केल में हमको दिख रहा है कि यहाँ से अगर हम पीछे ले जाएंगे then at a point we will get 0 Kelvin temperature, that is called as absolute 0 temperature. Okay, but in actual sense attaining absolute 0 temperature till yet has not been possible. जो closest temperature अभी तक जो attain किए हैं साइंटिस्ट ने, that is around 10⁻⁻10 Kelvin or 10, you can call 10 picokelvin. 10 picokelvin is the closest temperature which scientists have attained. Okay, but absolute 0 Kelvin temperature is not yet attained. Getting this or not? Okay, so this is the speciality of this absolute 0 temperature. और one thing more, उसके absolute 0 temperature के पास में जैसे ही हमारी गैस जाने लगती है, okay, it behaves in a different manner. उसमें then super conductivity आ जाती है, super fluidity आ जाती है. These are different properties which is observed if a gas is taken near to that absolute 0 temperature. Getting this one? Okay, so this is how we can define this absolute 0 temperature at which the volume of the gas disappears. There is no volume of gas. The volume of the gas disappears at this particular point at absolute 0 temperature. So attaining this absolute 0 temperature is not possible.